Hey guys, so we are going to be doing a short video where I'm going to do a practice worksheet for you. I know that I just went over some notes over how to do covalent bonding, but I felt like I needed to kind of demonstrate it a little better so that you guys could fully understand what I expected of you on the worksheet. So I'm going to share my screen here and show you guys what I'm talking about here. So what we're going to be doing is we are going to be drawing out the valence electrons, and we're going to be showing how many bonds are formed, single, double, or triple covalent bonds. So the very first thing is I'm giving you a set of 5 compounds, covalent compounds, and then you're going to use these compounds, draw the valence structures, show what's sharing between the structures, and then draw the bonds. So let's just start off with the very first one. So what we're going to be doing is Cl2 is for the first one, okay? Which means it's chlorine bonded to chlorine. So we're going to have Cl here and Cl here. Cl is located in column 17, so it's going to have 7 valence electrons for each chlorine atom. So what that means is if it already has 7, it only needs 1 more electron to make 8. So it's going to share 1 between each chlorine, where this chlorine is traveling back and forth across the bond. Remember, every covalent bond can only have a maximum of 2 electrons. So 1 pair equals 1 covalent bond. So now, after I show you the valence electrons, on the right side, I'm just going to show you the bond. Okay, so that's a single covalent bond between 2 chlorine atoms. Okay, and that's the molecule for Cl2. Now the next one I'm going to do is SiCl4. So remember, when you have multiple, more than 2 elements, one of them has to be centrally located. Usually it's always the first element listed in the compound that's going to be your central element. The only exception is hydrogen. Remember, hydrogen can only have a maximum of 2 electrons being shared total, so 1 bond. So it can never be the central atom. Sometimes, though, hydrogen is written first, so it's confusing. But every other time you have a compound, the central element listed here that we're going to be dealing with is going to be the first element listed. So for our purposes here, we're going to have SiCl4. So we're going to have Si, and then we're going to have 4 chlorines surrounding the Si, like so. Okay, now each chlorine is in column 17, so each chlorine is going to contain 7 electrons. Okay, so you draw those dots around each chlorine. Okay, now silicon is located in column 14, so silicon is going to have 4 valence electrons in the central atom. Now, because silicon has 4, it can share a maximum of 4 electrons, giving it a total of 8. But remember, each chlorine individually has 7, so therefore each chlorine can only share 1 electron. So what we do is we're going to share with that chlorine, the silicon's going to share with that one, share with that one, and share with that one. So now everybody has 8 electrons. So now I'm going to redraw this on this side, showing you all of the bonds that have formed between the silicon and the chlorine. Notice there are 4 lines touching silicon. That means silicon is sharing a total of 4 electrons with the 4 that it already had to make 8. Each individual chlorine is only sharing 1, so therefore that satisfies each chlorine so that they have 8. Okay, so these are all single bonds that you've seen so far. Now let's look at the next one, P2. That's phosphorus bonded to itself. So I'm going to put a phosphorus here, and I'm going to put a phosphorus there. Now, phosphorus is located in column 15. Okay, so phosphorus has 5 valence electrons. It needs 3 to make 8. Okay, so each phosphorus has to share 3 electrons to make 8. So it's going to share 1 here between the 2, another 1 here, and another 1 there. Okay, so it's sharing a total of 3 electrons because each phosphorus needs 3 to make 8. So now when I draw it over here, I'm going to draw 1, 2, 3, and there's my phosphorus. Now this has a triple covalent bond. Anytime you have 3 lines connected in one spot, okay, not around the element, but in one spot, that's called a triple covalent bond. okay? Now, phosphorus does have unbonded or lone pairs of electrons around it, which will affect the shape, but we're not going to talk about a bunch of different shapes and things in this chapter. So just note that we're just looking at the bonds. So that's why I'm not representing this with the unshared pairs of electrons, because right now I just want you to focus on looking at the sharing of electrons and then drawing the bonds between them, okay? All right, next we have CO2. So that means we have 3 elements here. So one of them is going to have to be centrally located. So I'm going to put carbon in the middle, and I'm going to put an oxygen on each side of the carbon. Now, carbon's in column 14, so it's going to have 4 valence electrons. Oxygen is in column 16, so it's going to have 6. Okay, so as you can see, watch drawing those electrons. Now, each oxygen needs 2 more to make 8. Okay, it has 6, it needs 2 more to make 8. Carbon, on the other hand, has 4, so it's going to need to share a total of 4 electrons to make 8. So watch what happens. So it's going to share 1, 2 with this oxygen, and then over here it's going to share 1 and 2 with that oxygen. Okay, so now when I write it, I have carbon here, and I have a double bond between that oxygen, and I have a double bond between that oxygen. So as you can see, you can have 2 double bonds in the same structure, okay? But carbon can only have 4 lines touching it total, because it can only share 4 electrons, okay? And each individual oxygen can only have 2 lines touching it, because it can only share 2 electrons. All right, the last one is NF3. Remember, when we have more than 2 elements, you have to have something that is centrally located. So my nitrogen is going to be centrally located, and then I'm going to have a fluorine on each side, and then one below, or you could put it above it. It doesn't matter as long as you just have it in one of the 4 quadrants, okay? So now nitrogen has 5 valence electrons. Fluorine has 7. Okay, each fluorine has 7. Okay, so I'm going to go ahead and draw those dots out. So nitrogen having 5, it needs 3 electrons to make 8. Each fluorine only has 7, so it only needs 1 valence electron. So the nitrogen is going to share 1 here, here, and here, okay, to satisfy the fluorines and to satisfy the nitrogen. Now when I write this, I'm going to write it as N, F, F, and F, okay? And as you notice, all single bonds. Even though there's 3 there, it's still all single bonds because each fluorine is contributing, okay? All right, so I hope you liked that lesson. Give you a little bit of a knowledge on how to do the covalent bonding. So now it shouldn't be any trouble for you to do the worksheet. Now, if you want to print it out and then write it on the paper and then take a picture and submit it that way, that's fine. Or you can use your tools through Cami and you can draw these directly on the worksheet. That's entirely up to you. I'll let you figure that part out, okay? All right, I hope you guys have a good day. And let me stop share here and then stop.